Now we move on to the sixth presentation, for which I invite Mr. Harshvardhan, who is General Manager of DCM Shriram Limited, to make his presentation on the topic Enzymes Application to Enhance Process Efficiency of Ethanol Production from Sugarcane Syrup, a Techno-Commercial case study on sulphited syrup. Sir, you have 20 minutes for presentation and 5 minutes for question and answer. Welcome, Mr. Harshvardhan.
Thank you, Raskar Saab. Respected Director Sir and STI President Mr. Avasthi, thank you for giving me this opportunity to present this paper today. Very briefly, I will be presenting the paper because the time is the constraint. So, okay, today's topic is the enzymes application to enhance the process efficiency for ethanol production from sugarcane syrup, sir. So, at one of our units, that is the Ajbapur sugar, we have got the 4 sugar units and 2 distilleries. We tried this syrup ethanol from this syrup feedstock. The capacity of this sugar mill is 10,500 TCD, and the process is double sulfitation. We utilize this sulfur syrup. Approximately 30 to 33% of the syrup was diverted, and till date we have diverted syrup equivalent quantity of cane. We can say that is around 31 lakh quintals of cane has diverted for the production of this ethanol. Ethanol so far we have produced is approximately 2.3 crore liters. The capacity of distillery with BIB is 260 KLD. Total fermenter, we have 4 number fermenter having each have capacity of 12 lakh liters, and wash holding tank have capacity of 10 lakh liters, and average syrup bricks on which we operated was approximately 60 degree bricks. So these are the brief process parameters. The make juice, the bricks was in this range, and the VA, as we already have talked about a lot on this VA, the main culprit for the fermentation process, that moved from this 300 ppm to 1000 ppm, and at times it reached up to 3500 ppm in the concentrated syrup, sir. So it also, the TRS also got concentrated, and the TRS ranged from 53 to 56%. And as already told by eminent speakers, it is very prone to contamination. All these 3 products, mixed juice, clear juice, as well as syrup. The basic problem with the double sulfitation plant is that the sulfate content that is also much higher compared with the this defecation process, that was ranging about 600 to 700 ppm in the unsulfured syrup. So we distributed for the study purpose. We distributed this process into two steps. One, what we when we started initially, what was the status that was operated from 6th of November to 26th of November, when we utilized the in-house culture and yeast, whatever we were using with the B heavy molasses or C heavy molasses, you utilized the same chemicals. The results were much erratic. Then we took the help of supplier Catalyst. They supplied some special dried yeast and enzyme boosters and some sanitizers, mill sanitizers. With their help, we got the improvement. In the subsequent slides, we'll be discussing about that. This was the before up to till the end of the November. What was the status? The average this alcohol percent in the wash was ranging between 10 to 11% max. The fermentation time, there was a lower ethanol yield was there. There was inconsistency in alcohol percent in wash. The fermentation time was as high as at times 55 to 60 hours a day for each fermenter. There were the higher residual sugars. As you can see from the graph, it was ranging from 2 to 3% residual sugars were there. The gravity was set up much higher. There was inconsistency in attenuation rate, loss of available sugar due to residual sugar. So we investigated why this is happening, why there is an increase in the VA. As usual, in the sugar plant, there is a lot of contamination happens, as earlier explained, at the mill level, at the filtered juice, in the clear juice, because all are perishable products. So we have to take care of that. Also on the distillery side, there was a stress on the yeast. The multiplication of yeast was not taking place as that was happening with the B heavy and C heavy molasses. There was a VA level was increasing up to 3,800 at times. This was because of the holding of this syrup in the pipelines, because the pipeline for the transfer of this syrup was almost 800 meters. The distillery is located almost 800 meters away, so there is a long pipeline. And also during this VA has adverse impact on the yeast productivity. Also, the sulfate levels were also in the range of 400-600 ppm, because it is a double sulfitation process. Although we were using unsulfured syrup, because of this, in the fermentation side also, high stress on the yeast was happening. This is the graphical representation how it was got accumulation of this VA happened. In the primary juice we analyzed, it was much lower, and at the unsulfured, the highest level we obtained was that 4,352 ppm. Because, similarly, the sulfate content was also getting concentrated in the sulfur syrup. So what actions we have taken? We started as usual. Before coming B heavy into picture, there was a great pressure on the sugar technologists for the recovery side. What we used to do, we forget for few days, for few years, that we need to clean the boiling house to take care of the boiling house sanitary condition. We again started with this operation of syrup, this cleaning and washing, application of this mill sanitary chemicals, filtrate clarification system, regular steaming, and also some specialty chemicals supplied by this catalyst. They helped us a lot. The lactic acid was there, that we used their special chemicals, and with this there was a quite an improvement. The VA was reduced by almost 40%, from 4,300 ppm to 2,500 ppm. We also optimized the lime and sulfur application. The sulfate content got reduced to 300 ppm. So you can see the trends, how this has happened. On the distillery side, also we started with, also took up Dr. Patel, as explained in the earlier lecture, that their team also visited. They have suggested certain actions. We also did that, and we started proper CIP of caustic cleaning of PHE in each pre-fermenter before filling, dosing of chemicals, special chemicals, slow feeding of syrup to reduce sugar osmotic stress, and shifting of spent wash from parallel to after syrup feed to reduce toxicity. So you can see in the graph, before optimization and after optimization, there was this total fermentation time got optimized, although it still ranges between 48 to 50 hours, but earlier it was very erratic. And alcohol percent in the wash also, we were able to operate in 11 to 12%. Earlier it was ranging from 10% to 11%, not more than that. We also focus on these sanitary conditions. We applied this particularly for lactobacillus bacteria, special chemical to reduce lactic acid stress on the yeast, and also complete dry yeast format to maintain the healthier and higher cell count to reduce the fermentation time. This is the syrup VA levels. What happened before? What was happening before optimization, and after this actions, whatever we have taken already described, then the VA level got down up to level of 2000 and range between 2000 and 3000. This is the bricks variation was very large before optimization. It ranged from 59 to 67, at times less than 59. But after the optimization, we also focus on the syrup in the sugar plant, and we try to make it consistent. Although in the sugar milling, there has to be variation, but we try to optimize it. So further, this is the TRS range. Based on the analysis, it was earlier it was in the range of 51, 52. Later it improved to 55, 56. This is the UFS level during the before optimization period and after optimization period. So this is the SO2 content in the syrup. It was much higher earlier. Later it was optimized and it ranged from 400 to 500 ppm, which because this high SO2 content impact the yeast product, especially in fermentation process. So these are the process steps which we did. This use of pre-hydration 20 minutes at the rate of 35 degrees temperature with continuous recirculation of agitation to use active dry yeast, addition of this 300 ppm nitrogen, urea, both in CVs and PFs on working volumes, addition of 20 ppm this DSPN on CV, PF. Similarly, on the fermenter filling side, as suggested by VSI, we followed that pattern. And we almost 30% recirculation of spent we started, and the process was optimized. This is the overall impact. What happened before? Before that, we were operating somewhere at the level of 200 KLD per day production level. With the optimization, we achieved the production level of 250 KLD per day production level. The average production for that period, we got 239, and before that was 200 KL per day. So these are some of the experience. As we all know, it is a clear feedstock. High value is obtained for the ethanol from the syrup. Higher ethanol yields with the syrup. Less concentration of organic acids are there. Spent was recycled. With the optimization, we can further achieve 40%, 50% recycle. Less fresh water requirement is there. Lower residual sugar. And still there are many challenges because it is a highly perishable product. We have to take care of all the hygienic conditions, addition of suitable biocides, chemicals. The syrup have higher pH with low buffering capacity, high osmotic stress, sugar stress, lengthier reaction time compared with B heavy and C heavy. Lesser nutrient availability, so we have to add more nutrients, and of course the low slope generation, so high energy cost, high ROI utilization. This is a simple calculation of the cost of chemical what additional chemicals we used with the application of this syrup. The cost was around 5 to 6 paisa higher compared with the B heavy. These are some of the data at a glance. The pole in cane for that period was approximately 12.5, and the total pole diverted after reducing all those losses in bagasse and press cake and unknown losses. The total pole diverted per unit of cane was 11.94%. The fermentation efficiency we achieved was 90.7. Distillation efficiency 98.7%. Overall efficiency we achieved 89.5. Alcohol percent in the wash for the whole period, including the optimization and before optimization, was 10.7%. The slop we produced was approximately 5 to 6 tons per hour, and steam consumption was in the range of 4.2 kg per kg or MT per KL. So we are currently operating with approximately 11 to 12% alcohol in the wash. So that requires high energy and higher water generation, lesser fresh water requirement. So with this experience, we are suggesting we should this higher cycle of fermentation, we need to install one more fermenter to cater the distillation requirement, because we run short of this wash to achieve the production levels. At the end, I like to thank Catalyst for supporting us, providing the solution, VSI for giving, National Sugar Institute for supporting us, giving the solutions, suggesting us the process steps, how to improve further.
Sir, you can quickly access through the Q&A section, sir. And
Okay.
in case you find some appropriate questions, sir, you can answer them, sir.
Mr. Pathak is also with us. Mr. Pathak? Mr. Dharmender Pathak?
Yes, sir. Good evening.
Yeah, there is a quick QA section. Please answer that questions.
So, how to control the VA and sugar syrup reduction year for the 91% achieved. We have achieved 92% level improvement, more than 97% how we achieved in indigenous condition. So I'm taking this, I was under the impression that the fermentation time is of the order of 16 to 20 for molasses fermentation. However, speaker refreshing for 45 to 50 hours. Actually, in syrup fermentation, there is a stress of sulfides as well as higher sucrose concentration. So it requires comparatively higher fermentation time, higher retention time. It should approach between 40 to 42 hours minimum. But in case of molasses, due to higher nutrients and the lesser stress of sulfides, it takes comparatively lower fermentation time. The result before and after optimization do not show, statistically speaking, any appreciable improvement. So before optimization, the plant was running on around 200 kLPD, which was and the fermentation time was around approx 60 hours. So after optimization, we tried to reduce all the volatile acid contents, sulfide contents, and maintain the process along with the help of BSI and the help of sugar persons and distillery persons. After that, we will increase the amount of alcohol production per day. It's reduced to 255 approx, and overall reduce the fermentation time from 60 hours to 42 hours. While using 30% syrup bricks for ethanol production, how was the bleeding system adapted to achieve 60 bricks syrup in the sugar plant? Its last question is not, I can't understand what they are saying. Anonymous attendees. We will take this answer and send by mail.
Okay, sir, not an issue, sir. Over to Raskar, sir. Sir, you can proceed further.
Thank you, Mr. Harshavardhan and Mr. Pathak. The beauty of your presentation is that you explained the topic with graphical representations, and also you have produced the data, so which was easy for the digesting, and you also explained PA and sanitary conditions with a very nice manner. So thank you for the presentation.
Yeah, we are very grateful to Shriram to give us this opportunity to make this happen.
Thanks.